But so again, I just wanted to go back to looking at your extensive background, right? And you know, we talked a little bit about machine learning. We talked a little bit about some of the other things, right? SPSS versus R, and some of your background, your history, and your story. But data mining, right? Data mining was in there, and so many people. We talked about this. When I look at data mining, right, I think that is one of the, if not the most important part or process through the transformation process. You know, to getting your end results of your data set or what you're trying to look for, and everything from looking at identifying unique patterns, right, doing the cleanup process, all that stuff that people don't really care to do. You know how important that is. I see it done and it's used a lot in the industry. What are some of the problems that you see data mining solving in the industry, or have you seen it solved?
Oh, well, you know, in many ways, I think of myself much more as a data miner than a statistician, but the names are always changing, right? So,
Mm-hmm.
you know, just a little bit of personal history to kind of get people oriented to the date. So, you know, I mentioned I started doing that SPSS gig winter in 97, 98. So in 99, two interesting things happened that influenced my career. Um, SPSS was a fairly small company. Uh, you know, it was like $250 million, but 250 million is like a rounding error
Yeah.
for, you know, for you know, some companies now. But they bought a much smaller company that
Mm-hmm.
made a predictive analytics workbench, which at the time was called Clementine, and then eventually through acquisition became the IBM, you know, predictive analytics workbench. But anyway, since that was there, that was in my world,
Mm-hmm.
and I became an early adopter of that. It certainly in North America I was, because it originated in Europe. So that really changed my career, because I started doing more machine learning and predictive analytics that early. That was just 2 years into it. And I
Mm-hmm.
started to slowly make the shift. So, you know, it was like all stats, and then it was like 80% stats. And then, you know, next thing you know, it was 20% stats,
Mm-hmm.
like 15 years later. So that was a big deal. And then the other thing that happened is that a couple of the folks, and I still know them, a couple of the folks that were part of that acquisition had been on another project. And that project was to write, well, manifesto is the word that comes, but that
Mm-hmm.
has political connotations. But, you know, like the Agile Manifesto, you know,
Mm-hmm.
everybody knows that, which I guess was written on a ski weekend. I'm not sure if you know that story, but apparently it was, most of it was written like over a 3-day period, and there was a lot of drinking involved or something.
Right.
Kind of funny story. But they had just spent 3 years writing the cross-industry standard process for data mining,
Mm-hmm.
CRISP-DM. So that was written between 97 and 99. And a couple of the guys that relocated to the US through the acquisition of this predictive analytics workbench had been part of the authoring team of that document, which involved like a couple hundred organizations. It was a really big thing. So all of us that were learning Clementine at the time were also learning CRISP-DM.
Mm-hmm.
And CRISP-DM to this day is still the most widely used predictive analytics process. Now, everybody ends up renaming it and changing around. So all these circular diagrams about, you know, start here and then move to this step and so on in predictive analytics all originate with CRISP-DM. So that was, you know, and that was, I was in my early 30s. I was 2 or 3 years into my career job. That was a defining moment for me. So it's still an important part of my career now. So we might not call it data mining anymore, but what's described in that document is absolutely still done. So I think the best way to answer your question about, you know, where do I see the greatest impact? Some people might answer by industry. So they would say, oh, it's really affected like banking or marketing or what have you. But for me, and this will sound technical at first, but I think it's the best way to explain it. For me, the most powerful applications of data mining have been in predicting binary outcomes, what you might call a binary classification model.
Mm-hmm.
So will the person pay the loan? Yes or no? You know, will the machinery fail? You know, should it be taken out of service? Yes or no? Oh, here's an interesting one. I'm looking out my window in my home and I can see commuter traffic heading home. What will a utility pole come down in a storm? You know, predicted at the individual utility pole level, right? These kinds of binary outcomes. That's a classic application. And in my experience, it probably involves 70 or 80% or more of what we do with traditional machine learning and predictive analytics, because those are the things that get you your ROI, you know?
Yeah. I've seen it a lot in like customer, like pattern recognition within like database marketing or something like that, or even maybe potential like terrorist threats in the government or something like that. Is this person a terrorist or not? But I do see what you're saying as far as the binary outcome. I mean that, yeah, you hit it right on the money. You know, I mean, I agree with you completely. You know, and I think it solves many problems in different industries.
Well, in marketing, it's the classic, you know, there are different ways of looking at these problems, obviously. So you can do more like the association rule. If you like this book, you also like that book, which is
right.
not exactly a binary. That's a, you know, more what we, you know, what we call association rules and stuff. But a lot of it is, will they redeem the coupon? Will they stay our customer? So the classic ones going back to the 80s are very frequently these binary outcomes. So I usually answer in that way because it's really not industry specific. Over the years, I've worked with clients in manufacturing, banking, insurance fraud, even did a gig with you know, Army Recruiting Command, where it was basically a marketing gig. It was, is this an offer that would appeal to someone that's trying to, you know, the way that we've structured this, would this appeal to someone that's trying to pay their way through school or something like that? In other words, basically doing a marketing segmentation of people that were thinking about the military as a career. There are knocks. I remember driving out to Kentucky several times, which is not a quick drive from Raleigh-Durham. It's doable.
Yeah.
A nice drive too.
No, that's some interesting information right there. You know, you've had an extensive background for sure. You know, and I think that plays a lot. And that's probably something that we can drop in as a, you know, to do for all the people out there that are interested in data science. You know, experience it, be exposed, you know, to many things, because that's the only way that you'll be able to really embrace, I feel like, the data science culture. You know, you have to really dive in, and you figure it out along the way. You know, I know another thing that and this is probably my own selfish ask, right, or conversation. It's about, and it's only because I'm into getting into, I'm doing my PhD right now, and I am focused only on quantitative research right now, right? And when you look at quantitative versus qualitative methods and why statistics something that people pursue, right? I truly think that, well, I see it. I see that many people run away from statistics. And you made a great point earlier that statistics, that's in almost every, if not every, when you're dealing with your PhD, it doesn't matter, you know, what your PhD is in, you know, there you have to do some type of statistical research or analysis in there. And for me, you know, both qualitative and quantitative methods of the research play important roles in different types of like product development, or, you know, when you're doing your PhD, you know, but for you, you know, what if you were, I'll just put it simple, if you were doing a dissertation topic, right, you know, what would you prefer? Right? And I probably know the answer. Would you prefer qualitative, quantitative, or mixed? Right. And then, you know, why statistics? Why has that become such an important part in your life?
Well, I've always been kind of fascinated with qualitative, to be honest. But, you know, remember that I was basically a computer science psychology double major. I mean, it's not literally, I don't literally have a bachelor's in each, but they were almost equally split. The whole long story there. But again, I contemplated PhD in psychology, and I'm still interested in psychology now. So you can see how in psychology, qualitative can be really intriguing, right? So now the practical person in me, particularly since you know, since I'm older now and I'm, you know, I'm mid-career. So if I were contemplating grad school, and every once in a while I get curious about, even at this stage of my career, if I want to do it, you know, I've helped people enough, friends, colleagues, you know, with the PhD work, that I probably have a much more practical approach to that than if I had pursued it in my 20s. I think in my 20s I would have been one of these folks that did a really ambitious dissertation that never finished. I think that probably would have been my style in my 20s, you know. But now that I'm older, I'm much more practical about it. So if I avoided the qualitative, it would just be out of knowing how messy that can get. You know, it's just extremely difficult work. In fact, one of my closest friends, who's a clinical psychologist, I got to work with him and his graduate school mentor. They actually did a little SPSS workshop for them, and then, you know, during chit chat we would talk about different stuff, and they were doing like a qualitative research book, multi-chapter, you know, where there was about 30 authors, you know, where there was a lead author, and they're doing all this stuff. So I have a sense of just how many sleepless nights and endless weekends, you know, that they had doing that kind of work. So I would be a little bit afraid to go qualitative, but that doesn't mean that I don't admire it when it's done well. But, you know, when you're doing a dissertation, you also have to live and pay the bills during that experience. And a lot of people don't finish because they get bogged down. So for that reason, I would probably tell people that if you're going to do qualitative, be careful.
Yeah.
But it can be really powerful stuff. Then in terms of what tool to use, you know, gosh, you know, you put it well, you know, when you were setting up the question, that an economics major doesn't have to know physics to do their dissertation. They don't have to know, you know, British Lit to do their dissertation, but everybody has to know some stats. You can't, right, no matter what discipline you are. So it seems to me that, well, frankly, somebody should use whatever they're the most familiar with. So whatever they took Stats 101 in, they should just stick with it. But the notion that, you know, it's not going to be sophisticated or something unless they're coding or something is crazy, particularly if they're a non-major and they're not going to go into machine learning or data science, because there's so many tools that would do a great job. You know, Minitab hasn't come up in conversation today, but when I took my first stats course, it happened to be in Minitab. I don't remember liking the course or liking the software all that much, but I know folks that are big fans of Minitab. Now, that was just because I was like 19, you know, when I took it. But folks that work in the Six Sigma realm almost invariably take their Six Sigma training in Minitab. So, you know, it's not just the famous ones. There's, well, Minitab itself is pretty famous, but there's a dozen different stats packages. So, and they're all supported on university campuses. So if someone,
that was one of them.
Yeah, you know, so it's crazy to limit yourself just to R. So, you know, in the workplace, can I see why people get fired up about open source? You know, even open source isn't free. You know, you gotta support it. You gotta provide training. You gotta have infrastructure. So you want to be thoughtful about these decisions. But if someone's doing a dissertation on, and, you know, by definition, they're in some kind of academic environment, right? Which means that they have student versions of this software. Don't limit yourself. Don't overthink it. You know, most people in their dissertations are not going to need, well, if someone's using a neural net or something, deep learning on their dissertation, I think they're making a serious mistake anyway, because it's crazy technique, you know, on a dissertation. So what are you doing? You're doing t-test, f-test, regression, 20 different software packages that would be all very inexpensive to the grad student. Maybe not to the workplace, but they would all be inexpensive to the grad student. Don't limit yourself. Do whatever you've already taken some classes in. Don't overthink it. Work in an environment where you're comfortable.
Yeah, that's a great point. You know, I have a story. I guess I won't talk about the story too much, you know, but I remember just going through my PhD process right now. I had this grand idea of all these great things I can do with my dissertation, and I came to the conclusion. Well, somebody told me, a professor told me, they said, just speaking on what you just talked about as far as neural networks and all that stuff, you know, they told me, they said, do you want to graduate? You know, they said, if you want to graduate, you don't want to do that, right? Or you don't want to, make sure that you're spending the rest of your 7 years or 7 years or so trying to do your dissertation, because you decided to pick a topic where you need all these different permissions. You got to do all these different crazy things, so yeah, that's just something that came to mind when you when you mentioned neural networks,
Yeah.
for sure. But so we're coming close to the end, but I wanted to have a little bit of fun, right? I want to talk about the future, right? And I have a little game that we can play afterwards. But something that you mentioned earlier that we wanted to touch on was what I hear is a lot of people, are asking, where is my career or my job going to go, right? Because the machine is here. The machine is going to take over it, right? They're saying AI is here, machine learning's here. They get nervous. They say, man, it's going to take over my job. And so for me, my thought process is, do not run from the machine. I think that was like my first podcast I put out there was like, do not run from the machine, embrace the machine. It's here to stay. And what you should do is start to, if you're depending on what age you are or where you are, what stage you are in your career, maybe start to shift your focus to some of the positions that's going to be behind the machine and being able to operate some of those. What's your thoughts on that? Should people really be scared? Are they going to lose their jobs? Where should they go? Things like that.
Well, jobs are gonna evolve. They're gonna change, but I don't think people in data science have to be worried about that.
Mm-hmm.
I'm going to be. We're recording this in early 2021, and I'll my next birthday I'll be 53. In the spring, and oddly enough, within the last couple of weeks, I sat down with my accountant to talk about how retirement works and all this kind of stuff. Anyway, I've decided that at the earliest, I would retire like at 67. The whole, you have to figure out Social Security and all that kind of stuff. Anyway, I'm only saying this to say, okay, as I look at my own career, I'll be at this for another 15 years and very likely another 20, to be honest, right? I don't think that all of the tasks that we do when we build a model are going to be automated while I'm still working.
Okay.
So, if someone's 19 and they're a freshman in college, I'm not going to claim to know what a 19-year-old might experience 50 years from now. I'm just saying I'm looking at my crystal ball out 15 to 20 years.
Mm-hmm.
And what we do with feature engineering and data prep, the way we have to talk to the business and set up the problem and define the problem, none of that is going away. So I think what's happening is, as praiseworthy as Kaggle is, because Kaggle is amazing what it's done for the machine learning community. In fact, I was thinking if somebody wants to do something a little bit risky, like try to use a neural net on their dissertation, the reason that's a problem on their dissertation is, again, it doesn't tell you what it's doing, right? Anyway, so that's a problem. That's a problem if you're doing a dissertation, even though it might be a good thing to do, like on a fraud model or something. Right. But anyway, the reason I bring this up is that, AutoML is just not going to get there. You still have to translate it into the business problem. And that's what you don't experience when you're doing something like a Kaggle competition. As amazing as the positive influence that Kaggle has been in the data science community, it is a modeling competition, just the modeling phase. So the phases of ChrisDM are business understanding, data prep, none of which, you could argue there's a little bit of data prep, but it's a sprinkling of data prep that you would do in a Kaggle competition compared to what you would be doing a real world project. Absolutely. And then, of course, you're just uploading your model. You're not going through deployment. You're not going through evaluation. You're not dealing with organizational resistance and so on. So, the folks that do what I do, all I can say is I consider my job to be very, very safe over the next 15 or 20 years. And not only because my career has moved more towards speaking and thought leadership and so on. I mean, as a practitioner, I'm not hands-on the model to the degree that I used to. I used to work with a client, and for like 3 or 4 months, it was nothing but that one client. Then I would move on to the next client. It's not that way now. I do a lot more mentoring and stuff, but that's not the reason I'm saying this. Even from the standpoint of someone that is still, involved in being a practitioner of what we do, that job is safe for the next generation. 100 years from now, I don't know. I don't think anybody knows.
No,
But
that's a great
like
point.
20 or so, for sure.
Yeah, and that's a great point. And I think probably the concern of the people that are probably really close to retirement anyways, and they shouldn't be concerned about that. They should be more concerned about, you know, how they're going to retire and what they're going to have after they retire versus, you know, are they going to have a job for the next 2 years or something?
I'm not so well. I'll tell you what's a real issue. So much so that I'm hoping to have some kind of panel discussion about this, you know, sometime. Is I know some colleagues that are a little bit closer to retirement than me, maybe 5 years, 10 years older, about that, you know, so not early 50s, but early 60s. And they can't even get an interview. I mean, you're talking about somebody with 40 years of experience, and they can't get an interview if they don't take a Python test.
Right.
You know, it's not just competence in Python. They've got to like ace it, but like from memory. And that's nuts, because somebody that's been active in the community that many years, they know how to solve problems. So because they're doing the same thing in Python that they would have done in 5 other languages previously.
Yeah.
They just don't have Python memorized the way that a 22-year-old does.
Right.
So do you want to take the 22-year-old over the 62-year-old every single time? If you're building a young team and what you need is a person that basically just takes models and puts them into production and stuff like that, then I would go with the younger Python programmer because it's more the coding focus. But you want no one on the team that has that kind of experience with theory
somebody
or
in there.
much
I didn't
experience
think
with
about
clients. Crazy.
You're right.
Crazy.
You're right. I never thought about that. And it's a lot more than we probably think that are out there that are close to retirement and they can't find a job, but they are definitely more competent. They definitely can work through some of the problems probably better than, you know, half of the younger generation, right, in their 20s, because they haven't experienced or haven't been exposed to that much, right? And so they're just starting out and they get the position, but you have people that's been in the industry for years, and just because they don't know something, I mean, you think about like the Facebooks and the Googles and stuff, right? They're hiring, you know, and if you don't know their stuff, right, you know, then you're SOL, really.
Well, and again, these 3 friends actually, depending, I've heard a number of stories. They're all pretty similar to that. Basically, being quizzed on commands verbally from memory. That's just crazy, you know, because there's something to be said for 40 years of experience. There has to be some utility to that amount of experience dealing with clients, solving real problems. You know, it's just absolutely crazy to me that would be devalued to that, to that degree. Yeah, but you know, I think that younger people are probably worried about things like AutoML and stuff like that too. And for that reason, you know, at the moment, I imagine people are getting super excited about like autonomous vehicles and computer vision and stuff like that. But I don't think the insurance fraud and the bank default and the customer retention is going to go away. I really don't think those things are going away. So I would hate to think that somebody is interested in that side of the business and they get scared away because they think that that's all going to be automated. We're decades away.
That's going to take a long time, right? You know, because there's a lot more thought that has to be put into something like that to compare it to the human mind, right? And try to compare it to like the human actions and, you know, what they would go through. So I agree, you know,